The question asks, calculate the enthalpy of reaction for the formation of ethanol given 3 separate reactions and their associated delta H of reaction. For this procedure, we will be doing method A. In method A, remember everything has to be shown as a formation. So the key is to show everything as a formation, meaning all substances in the given reaction, the reaction in question, needs to be shown as a formation on the product side. So what you're going to do is you're going to look at your individual reactions, reactions 1, 2, and 3, and decide, all right, are the substances in the reactions 1, 2, and 3 that are in common to the reaction in question being shown as products? If they are, the reaction stays as is. If they are not, the reaction gets reversed, so they are shown as a product. And you manipulate the delta H associated with this individual reaction accordingly. So let's start. We're going to look at CH3OH. It's a reactant. Up here, though, it is obviously in the product end, so we need to show it as a product. Everything has to be shown as a formation. So what are we going to do to this reaction? We're going to reverse it. So what I will do is rewrite this reaction just in reverse. So that'll end up being CO2 plus 2H2O yields CHOH plus 3 halves O2. The second reaction, we say, all right, we've identified the CH3OH. We now have graphite. Graphite is, again, one of our substances in the reaction in question. It needs to be shown as a formation, so we need to reverse this as well. Oh, and before I forget, since we reversed the first reaction, we need to reverse the sign, so a negative becomes a positive. We are reversing the second reaction, so graphite is shown as a formation. So the second reaction will become CO2 yields carbon as graphite plus O2. Reversing the reaction causes us to reverse the sign, negative to positive. And in the third reaction, we have H2 and O2. And this reaction needs to show as a formation, so we're going to again reverse this reaction to show that H2O in the liquid state is being broken down into H2 plus O2. Now, something else to notice is that we have 2 H2s. Down here we have 1, so we need to double everything. We reversed it, so we have to change the sign, and we also have to multiply it by 2. So we're going to have a total of 571.6 kilojoules. Under method A, once you have everything appropriately reversed and manipulated based on the mole amounts being the same, by that I mean we had 2 moles of H2 in the reaction, we had 2 moles of H2 now represented in our third equation, and we manipulated the delta H accordingly. Your delta H of reaction based on method A is the summation of your delta H of formation for all of your products minus the summation of all of your delta H formation for your reactants. So in this case, we will have our product, which is CH3OH, our ethanol. That one will be this delta H because it has the ethanol. So it was going to be 726.4 kilojoules minus the summation of all of our reactants. So all of our reactants, which will be signified by these 2 delta H's. We have reactant 1, 2, and 3. So we will add those 2 delta H's together, and we would have 393.5 kilojoules plus the 571.6 kilojoules. And we will be able to calculate the enthalpy of formation associated with this reaction, and that is going to be equal to negative 238.7 kilojoules. Remember, the least number of significant figures or least number of decimal places when multiplying and dividing is least sig figs. The least number of decimal places is what we base on addition and subtraction for significant figures. So we know that 238.7 kilojoules are released. It's exothermic due to the negative sign for this formation of ethanol.